All right, this is the Mike and Tom Show, episode number 5, where we've decided to do a new library, and that's the Z pattern matching library for JavaScript.
And what do we do on this show?
Go through the getting started guides for new technologies that we want to learn and we want to help other people learn.
Yeah, and importantly, since a lot of these libraries are brand new, there's weird errors and just typos and stuff, and so we run into all that stuff when we try our best to try and sort that out so that we can A, make pull requests on GitHub that fix those issues, and B, it's exactly the experience of a normal developer going through these getting started guides. You're gonna run into issues. Things are gonna happen. We ran into some issues in the past. If you've watched any other episodes, then you would have seen that. So without further ado, we're taking a look at Z pattern matching. This is probably gonna be a short video given the length of the guide. What do you think, Mike? About 5, maybe 10 minutes?
We'll see.
About half of the page is just that footer area.
So my first question is, why is it called a native pattern matching library? Do you know?
I have no clue.
Okay, well let's get right into it then.
Okay, so we have a blank project file, and we gotta import the library. So let's get started.
Okay.
Actually, I'm gonna read this, and you can type. So I'm familiar with pattern matching from other languages, but it's basically everybody describes it the same way. Pattern matching is Switch on steroids, and usually that implies that you can dig into the thing that you're switching on and look at its attributes and do all sorts of cool stuff like destructuring. So we'll see what kind of pattern matching features are in Z. So just reading this aloud, you can create powerful conditions such based on object properties or array content without manipulating the object or array itself. That amount of power leads you to write functional, immutable, and expressive code instead of imperative, which reduces a lot of complexity and bugs. Debatable, but I'm not gonna die on that hill. So, well, I mean, okay. As long as you're typing, I'll just rant a little bit. Yes, immutability is good. Does that mean that functional automatically becomes a great thing as well? Not necessarily. Does it lead to more readable code? Not necessarily. Does expressivity lead to better code overall? Not necessarily. Anybody could say that Perl is highly expressive. Is it known for being unreadable line noise in the hands of a grizzled veteran?
In my experience, yes. Feel free to test my might while I'm typing.
Choose your might first. Choose your might.
It's always more fun when I'm trying to type when I'm also trying to answer questions. No,
Okay.
I'm just kidding. Yes, do that, but only if you
So
really want to.
that's my little tiny rant about why imperative code doesn't deserve to have dirt thrown on it at all.
I like imperative. I don't know what that means, but I like it. I wrote...
Most of the code you've ever written is probably written imperatively.
like procedurally?
Yeah. No. Not procedurally imperative. But you're using the terms interchangeably, which is fine, and who cares? The only person that's going to freak out at you is a technical interviewer who is overly pedantic.
Oh.
Yeah. All right, so output. Hey, Maria, you are welcome. John, you are not welcome. I like how you change all the strings all the time.
You know what's rough about this episode is we don't have our pretty print thing that we had set up for the last one.
Oh, darn it. Well,
I'm going to pause that and we're going to get the pretty printer back.
sure.
Alright, so we got our pretty print up there at the top.
Yeah, and then we realized we didn't need the pretty printer because we're console logging. But we will need it, I think. So go to WSL and let's run the thing. And we should see the exact same tutorial output. Ooh, whoa, whoa, whoa.
All the installation.
Hey Maria, you are welcome. Okay, let's look at what's going on here. So we did person named Maria, and now we're matching on object. And basically all we're doing is, on the left-hand side of those arrows, we're looking at the object. And in this case, we're essentially saying, if X equals name John, John, you are not welcome. So if we change Maria to John, we should get that first one, right? Yeah.
Did I save it?
I don't know. Did you?
Save.
Okay, so why is this an equal sign? I don't know. Let's do it double equals.
Must be a typo in the
No, I don't
example.
think it is because it's repeated all over the place. So
Kablooey.
yeah. So that is something that could catch you off guard. So what's interesting is we're getting, "Hey John, you are welcome," right?
Yeah. It's not rejecting us like we want it to.
Well, that's interesting. The first example, and we literally are not getting the same results by passing in John. That's okay though, because that's not what it was telling us to do. So let's go to the second example.
This one?
Yeah.
Type it all in now?
Yep.
Right out.
Let's just delete that too.
Okay, so
Yeah, delete all that. Yep. So we tried to change it to John, and then nothing happened, right?
I mean, I don't know. I have sort of a sneaking suspicion that I may have made an error, but
Oh, really?
I don't know.
It looked fine to me.
I like that.
So I think that this example is showing us that we can match on a value, we can match on a type. Oh. So I'm trying to figure out how this works behind the scenes. And I think it's probably inspecting X. I wonder if it's always X. Anyways, it's probably inspecting X, the instance, what it is, and based on what it is, then doing some sort of comparison. You alright?
I'm gonna explode.
Alright, let's run that.
What are we even console logging? Undefined. Does that mean I did it right?
I don't know. Pause the video, will you?
Alright.
Alright, so what that issue was, we had some stage 0 features enabled in Babel, and we didn't dig too much into where they were conflicting, but we just removed them, and now we're doing Babel straight up, no customization, and it works fine.
That if you are using some weird Babel presets that aren't fully spec'd out and approved, then you run the risk. So we're able to do the test just fine now, which no fault of the library. We get the correct output. And I bet that if we went back to the first example, that we would get the correct output if we put John in. So what do you say we do that really quick, because we're gonna copy paste it and then just change it to John, and then we'll get the same result.
Let's see what happened there.
Yeah. And change X, change the person to John. So we're rewinding a little bit. Apologies for the skip, but we just want to make sure that this is right. Gotta save. John, you are not welcome. Perfect. Okay, so that's what it was. Great. Let's keep going. Let's keep going.
Number 3.
We're gonna do this one. Yeah. To match array content, you need multiple arguments for that match function, such as a, b, c, tail. Then each variable match each item from array. Note, last variable contains all remaining array items. That's why it's named tail, formerly named tail. examples.
I really don't like this. Sublime doesn't know what to do with my parents when I go.
Well, I'm sure we can live with it. Alright, so we're matching on an array that goes from 1 to 2 to 3 to 4 to 5. And we want to specifically kind of implicitly destructure 1, 2, and 3, or the first 3 elements, and then the rest goes into tail. So yeah, actually what you're writing now is exactly, I don't know where those commas are coming from or going.
It's just an example.
Yeah. Let's do result 1 and result 2 so that we can actually see the results that we're getting. So we let result 1 equals, yeah. And then we'll pretty print those results. Okay, and I think the last one is the most interesting.
What?
Why are there 4 commas?
Let's see. The last one is the most interesting.
Let's do let result 3. Yeah, you missed that arrow. So this one is the most interesting. We've got 3 more or less conditions. I can't remember what the official terminology, clauses, I don't know. We have 3 conditions, A, B, and tail. So that technically should match anything that's 3 or more elements in the array. The second condition is A equals 2, tail is an empty. That should match when A equals 2, it's just a single item. And then the third one is A equals 1, tail. So that should match when the first one is 1. Anything follows. So as long as the first element is 1, then we should be good. Okay, so what I want you to do is pretty print all 3.
Oh my god, that's the second time that's happened. Okay. Yank. Place.
Yeah, let's run that. Okay, so
We
got the first condition as expected, the second condition as expected, the third one is an undefined. Find. Result 3 will not match here, A1, tail. Did it fall through? Let's do add a second element to 1, 2.
Yeah, should get the same result as the second one.
Yeah, and then, so I suppose that this is showing us. So that's interesting because the text seems to say that 1 be matched on the third one, but it actually won't. So the text says will match here, tail equals empty, but we passed it in, it was falling through. So that's interesting, and we might want to actually update notation.
Alright. Errors in every library.
Yeah. So,
GitHub it up. Should we do it now?
yeah, sure, let's just time it'll be real quick.
We'll do it live. I wonder if there's going to be other ones we run into.
Did you fork it?
Yeah. I don't think we need to though. It'll do it automatically. Let's see, what was the error? It was
The error
this
was,
one.
yeah.
What are we supposed to change exactly?
We're supposed to add an element because that third condition not working.
Okay. Let's
Your pull request, I think, is what you did.
new file
Oh.
and let's hit the edit button. And now that everything, here it is. Okay, so in this element we need, and that's it, right?
Yep.
And then
I want you to be specific in here too. So it's not a typo. We're making the example actually work. So how can we best communicate this to the person?
third example.
Yeah, third condition wasn't working. Yeah, good enough. So that third condition actually is caught. Third condition matches. How about that?
Yay.
Yep.
Gotta remove my old email from that.
This is totally the Boy Scouts approach, right? We're trying to better than we found it, right?
Yeah, and I don't think anything needs to change here.
Sure.
Sweet.
Okay, let's go back. All right, where are we? We're to the next example.
Alrighty, let's do this one now.
Powerful recursive sequential repeated items from array can be mind-blowing if it's the first time you meet pattern matching, but you are gonna understand it. I hope we do.
Yeah, right. If this last example we're just totally getting blown out of the water by.
Yeah.
Alright, well I guess I'm gonna type it all by hand.
Yeah, you are. All right, so I'm gonna try and read this and figure it out. So we get numbers.
The kerning on that O and that M there.
Okay, so compress is a function we're making. It takes numbers. The first condition is x, y, and x's. And what it does is if x is strict equality with y, then we want to call compress again, and we want to concatenate with x's, so we're removing y, it seems. And so if x and y are the same, then we want to remove y. And we also want to pass it in, so it removes duplicates from the left. If they're not, then x and compress y. Interesting. Compress y concat x's. X concat compress y concat x. So if they're not the same. Okay, so if they're not the same, then it's going to shift one from the left and then keep going. Interesting. Yeah, I think my brain can understand that. You already wrote it all. Sweet. All right, let's. We got to pretty print that too. Don't forget. Yeah, and there's the duplicates. Makes sense. I think that the only thing that might be quote unquote mind blowing is all of the usages of concat and the recursion. And I think that's it.
Let's see what happens when we do this.
Yeah, so it removes consecutive. Let's see if it removes. I don't think it removes non-consecutive duplicates. So let's put a 1 at the end.
Oops.
No. A 1 at the end. Yeah. Okay, it does. Yeah.
What a sweet example. Even though there was a little bit of an error in one of the examples, it's like we were able to figure it out.
Radical. So I think that that's actually a pretty powerful library. I think that if we had broken up that, I'm not really a fan of lines 11 through 13 simply because of the indentation of it and the fact that it confuses the syntax, which might be confusing to begin with if you're not a super newer function syntaxes. Doesn't really matter at the end of the day. I'm just looking at it at a glance and saying like, whoa. But a pretty cool library, and there was only really one mistake that we